Contact is a way in which electrons can be transferred from one conductor to another. Remember last time we mentioned that we have got friction as our first method in which electrons can be transferred. So here the aim is to actually charge objects and make them equal. So here this happens between two conductors. So this is one conductor and then this is another conductor. So this conductor, let's name it A, and this is conductor B. So note this, the conductors must be identical. So they must be of the same kind so that electrons can be transferred. So here the whole point of contact is to actually make the charges equal. So for example, we're having here a -2 coulombs. The coulombs actually a unit for measuring the amount of charge an object has. And then this one is 0 coulombs. We're having object A having a negative charge of 2 coulombs and then B having a neutral charge. Note this, a neutral charge means that the number of electrons and the number of protons are equal in an object. So here for A it is negatively charged, meaning that it has got more electrons than the protons. So if you didn't understand exactly how to see the charges, please rewind back on our videos introducing electrostatics. So here, what is the whole point of contact? The whole point of contact is for object A, which is having more electrons to transfer those electrons to object B so that these can be two equal objects. So here, the point here is for B to actually be in contact with A. So let's say B here to come in contact with A. So when B comes in contact with A, what is B's motive? So B has got a motive to get electrons from A. So A has to transfer a charge to what? To B. So let's see, how do you determine the amount of charge that will remain on A and B after the transfer of the charge? So here we use this formula that say Q nu. The nu is telling us that we've got a new charge. So Q is representing the charge and then the nu is telling us that this is the charge which we have after these have come in contact. So in the statement questions they will actually tell you that calculate the charge on each after they've separated. So they have to be in contact first and then separate. So the whole point here, it is to add their charges for QA plus the charges for QB and divide them by 2. This way you actually see how much charge remains in A and then how much charge goes to B. So the charge which will remain in A, it will be the same charge that will go to B because charge is conserved here. Charge is not lost in any way. So the charge that is coming from A is going directly to B without being lost anyway. So the amount of charge that is coming from A, it is the amount of charge that B is receiving. So here, let us add the charges which we have. We are having -2 coulombs of charge in A and then we add it to 0 coulombs of charge in B. So how much charge do we have remaining on A and B after the transfer of charge from A to B? So here we divide it by 2. So here let's see the new charge on each of these spheres or on each of these conductors after contact. So here -2 plus 0, that's going to give you -2 divided by 2, that is equal to -1 coulomb on each. So you must mention specifically that this charge, it is the charge that remains on both of the conductors. Remember that the aim of contact is for the conductors to be equal in charge. So this is the whole point of contact. Next video, we're actually going to talk about induction as a third method in which electrons can be transferred. Thank you for watching. Don't forget to subscribe. Tell your friends to stay tuned.